Hi, my name is Ayan, and in this video, I'd like to show you how to use Mutable Plugin with Metahuman characters. In this video, I'll be focusing on the Mutable as an in-editor tool, meaning I will be skipping over some mutable concepts such as states, instances, runtime variables, but most things that you learn in this video can be used in runtime workflow. I'll be using Unreal Engine 5.6 and utilizing Metahuman Creator. You can follow along in Unreal Engine 5.5, where Mutable Plugin is available as beta as well, but you'll have to source your Metahuman assets in another way. Also note that depending on the version of Metahumans, their assets can differ a bit, and in such case, you will need to adjust. Mutable is an inbuilt plugin in Unreal Engine that allows you to dynamically generate skeletal meshes plus materials and textures for them. It has a very powerful set of customization tools and allows for very flexible ways to modify your assets. That being said, it's still in the beta phase, so not all workflows have been ironed out and expect bugs. And specifically for Metahumans, the Groom and DNA support is still in experimental. And in fact, we'll be skipping Groom usage in Mutable because currently it only supports runtime workflows. Please do check official sample project and documentation. They are awesome and great for starting. Okay, let's create a new project and dive straight into it. I'll create a new project in 5.6. It will be a blank project under the games category, and I will call my project Mutable Tutorial. Great. Alright, we have a brand new project. Now I will scale up the UI so you guys can see what's happening. First things first, we have to enable the plugins that we will be using. It is Mutable Plugin. Rig logic extensions for Mutable are required to work with DNA data. We also need to enable Metahuman Creator. Okay, now we can restart. Now we can start working. First, let's create a Metahuman. To create a Metahuman, I'll be using Metahuman Creator asset, Metahuman character. Let's call it Bruce because I already know who I want to use. Okay, first time you start working with Metahumans, there will be a pop-up that asks you to enable some settings. These are important. Let's enable them. So once you enable them, it will ask you to restart. Let's restart right now. Yes, I will save that. Now, our Metahuman. So creating a Metahuman in Metahuman Creator can be a whole series of videos, and it is outside of the scope for this video. So I will be just using a preset, and you might have guessed it. It is our friend Bruce. Since we're using Mutable, I think it's preferable to do customizations for clothing in the Mutable and have the source meshes have all the information we need. In our case, we need to have information about the underlying body of the Metahuman, so we can be more flexible about what types of clothes we can wear on that Metahuman. So I will just disable default clothing. And before we can assemble our Metahumans, we need to create a rig and download textures. Okay, so once the rigging is done and we downloaded our textures, now we can try to assemble our Metahuman. Let's save first. So I'll be using the top preset UE Cinematic Complete because using Mutable we will be able to optimize it down. Alright, it took a while, but it did assemble our Metahuman, and we can find it in Metahumans folder under Bruce, and this is our Bruce. We need to save everything. Okay, now we have our Metahuman, and we can start working with Mutable. I will create a new folder for it. I'll call it Mutable, and I'll probably make it green so it's easier to see. So for Mutable, we have to create customizable object asset. It is under Mutable category. And let's call it customizable object Metahumans. Metahuman, right? Let's double click to open it. Once we open up the customizable object, we're greeted with Mutable Editor. Generally, it behaves like a blueprint editor. You can search, drag pins, and it will be context search. You have a details panel. When you choose a node, it can display the details of that node. We also have a viewport, which is currently empty, and we have preview settings, so we can test what we created. And we also have preview instance tab, which shows us what exactly we generated using this customizable object. Now let's reference our skeletal mesh inside our mutable graph. We can do that with the node called skeletal mesh. And inside our details panel, we can choose our skeletal mesh. Let's choose SKM Bruce face mesh. Since we are working with complex metahumans, we have a lot of output pins. Usually what I do is I'm hiding them all and unhiding only those that I'm working with currently. This skeletal mesh node does a lot of things, but what we really care about right now is its output pins. There is two types, mesh and texture. We don't care about texture right now. And each mesh output pin corresponds to a mesh section on this skeletal mesh. You can always check mesh sections on the skeletal mesh by just opening skeletal mesh and going down to LOD. And under LOD you have sections. Each LOD can have a number of sections, and each section represents a geometry with the same material applied to it. Now let's go back to our customizable object and enable the very first section that we see here. It's a LOD0 section 0. If we drag off from this pin, we'll be able to define it as a mesh section. In Mutable, mesh sections is one of the main places where modifications to skeletal mesh can be done. They can use different material, different textures, and they also can be targeted by modifier nodes. Once we have our mesh sections, we can combine them into mesh component. Mesh component is a node where you can combine several mesh sections into LODs. You can define how many LODs you want in your final skeletal mesh. Let's not do it right now because it will throw error if nothing is connected. And in this node, you have to define a reference skeletal mesh. It will be used for LOD settings, for bounding volumes, for physics, and etc. When working with metahumans, official documentation suggests to use face archetype skeletal mesh as a reference skeletal mesh. But I am noticing that in the newest metahuman versions, this skeletal mesh doesn't exist. So what I'm currently using as my skeletal reference mesh is the character skeletal mesh. And it usually works for any metahuman because the post-process animation blueprint is practically the same for all of them. And the only thing that we need to care about is DNA. So let's set our reference skeletal mesh as the same skeletal mesh that we'll be referencing here. It will be SKM Bruce face mesh. And let's give this mesh component a proper name. Then we connect our output pin to components, press compile, and we have our first generated skeletal mesh. In the preview instance tab, you can inspect what exactly was generated. And right now we have one skeletal mesh generated and one material. If we double click on these assets, we will be able to inspect them in detail. But keep in mind, they are temporary assets. And if you want to save them, you have to bake instance. Now, this basic graph generates skeletal mesh that consists of a single mesh section. And our metahuman here has 8 on LOD 0. So let's add more mesh sections of the same LOD. We can filter for the same LOD by just typing LOD space 0, sort by type on output pins. Let's enable all LOD 0 mesh sections. Now let's add all mesh sections to our mesh component the same way as we added our mesh section 0. By the way, if you are dragging pin from the mesh section to create a mesh section node, it will be automatically populated with the material on that mesh section. If you're creating mesh section node from scratch, it will not. Just keep it in mind. Now let's press compile, Save, and let's see what we have. We have 6 mesh sections because I did skip a couple that has material M height, which is just transparent material. We can also disable eyelashes material because this material essentially is a translucent material with opacity of 0. This is because in cinematic quality metahuman they usually use grooms for eyelashes, but in our case, if we decide that we want to have a textured mesh section for eyelashes, we can do so. For that, let's select our mesh section, let's hide out all the pins that we are not using and enable opacity and hair melanin to control our color. By the way, if you're not sure what each parameter does, you can always open up the material and play with that material here. Just be sure to reload your changes so we're not polluting the source assets with our modifications. The reason why we don't want to modify original assets is because in case we need to adjust our metahuman in Metahuman Creator and reassemble it, our changes are not lost. It's preferable to do all the changes inside of a mutable graph, so we have a consistent end result. So going back to our mesh section, we can set constant values for our material parameters using node called float constant. We click compile and we can see that we have eyelashes. Sometimes this viewport may be late to update. In that case, you can open up the final skeletal mesh and double check it here. Now we have recreated LOD0 of Metahuman. Let's test how it works with animation. To do that, you can set animation in our preview settings under animation, and let's choose ARKit mapping animation. You can see that our output skeletal mesh is moving, meaning that our DNA is working. By the way, DNA is coming from our reference skeletal mesh, but there is something strange about it. If we zoom in closely, you can notice that some strange things are happening with vertices. This is happening because of incorrect weight data on vertices, because Mutable by default has a limit on how many bones can influence one single vertex. And to override that, we have to use a setting in a config file. You can find information about it in official documentation for Mutable working with Metahumans. This config file can be found in your installation of Unreal Engine, in plugins, Mutable config, and the file called defaultmutable.ini. If we open this file, we can see the settings that are available for Mutable. And the one we are concerned about is this, called Customizable Object Num Bone Influence. And as per documentation, we need to change it to 12. But instead of changing config file in the engine folder, I usually prefer to have it localized to a project. So we can recreate this file in the project config folder and just copy paste this part. So in our project folder, in the config folder, we can create a new text file and call it default mutable. And let's change the type to ini. Yes. Now let's edit this file and just copy paste that part. So right now this line is commented out. We just need to uncomment it and change the value to 12. Let's save it, and we need to restart our project. Just for the reference, I deleted comments and zoomed in so you can see it more clearly. This is what you have to have in your config file in your project config folder. Once we reopened our project, we can go back to our customizable object and check for the same problem again. As you can see, our vertices have been fixed and the animation displays correctly now. Documentation also suggests to enable 16-bit bone weights. You can access this option by selecting nothing and down in the details panel. Let's do that. Compile and save. And now we have successfully recreated LOD0 of our metahuman. And we even optimized it a little bit by discarding mesh sections that have transparent materials. Now for other LODs, you don't always have to redefine each mesh section again, but it depends. For example, let's add one more LOD to our mesh components, so it will be in total 2 LODs, and compile. Here in the viewport you can select LODs you want to inspect, LOD0 is the LOD that we created, and we can see LOD1 has pretty much everything except the head mesh. Why is that? To understand the situation, we can inspect the tooltip of LOD strategy. And simply speaking, it means it can recreate mesh section for the next LOD if this mesh section exists and uses same material. So in our case, each mesh section except the head has next LOD with the same material applied to it, but the head mesh section has another material. We can inspect that in original skeletal mesh. Here in original MetaHuman skeletal mesh, we can see the section 0 uses material called head shader. If we change to LOD1, our section 0 uses head LOD1 shader, which is different material instance. This is why for LOD1, we have to redefine our head mesh section. Here we have two LODs defined for our MetaHuman character. You can also notice that LOD1 doesn't have eyelashes, because for the same reason it uses another material. We can just add it in the same way we did with head mesh. And now we have eyelashes for LOD0 and LOD1. Notice that they are different colors because we did not set the material parameters. And now we have MetaHuman face with LOD0 and LOD1. If we wanted to add LOD5 from original skeletal mesh to our LOD2, we would have to redefine all the mesh sections again because we are not doing them sequentially. So once your graph becomes sufficiently complex, it is generally a good idea to break it down into subgraphs. And in Mutable, this can be achieved with external customizable objects. Those are created the same way. They are standard customizable object assets. Let's create one now and call it customizable object face. Let's copy everything that we did so far into this new customizable object. Compile to see if everything is working, and I went ahead and added colored comments so it's easier to distinguish between the two. Child customizable object is green and parent is red. So to add external customizable objects into our parent graph, we can use a node called object group. Object groups can be used to handle a collection of customizable objects. For example, in our case, we can handle everything related to a head skeletal mesh in this group. In fact, let's rename it to head. And there is a parameter that tells Mutable how to add objects from this group into final result. Since we're using head, we want it always to be on. We're choosing all options. You would also notice that object group doesn't have a parameter to select childs. It is child have to assign themselves to an object group. And to achieve that, we have to go to the child object, select the base object in that graph, and in a section attached to external object, we can select our parent object, customizable object MetaHuman, and within that parent object we can choose the group, and in our case it is head. Whenever you're configuring the attachment to external objects, don't forget to save your assets, because otherwise these changes will not propagate to the parent objects. So let's save, and if we'll compile right now, it will throw an error. This is happening because we have mesh component with an identical name. And even if we go to our parent customizable object and disconnect component pin and compile, it won't generate any meshes. I'm still not quite sure why this is happening. It could be I'm missing something, or it could be a bug in Mutable. One of the workarounds is just to connect a dummy mesh component. It can be anything with any skeleton. Compiling with this will generate our skeleton mesh, the correct skeletal mesh. But I feel like this is not the correct way to do that. So I will retract my changes and go to the child customizable object. And here, instead of adding new mesh component, we can use a node called add to mesh component. We should use the same name as our target mesh component. Let's move pins with control. Let's define same number of LODs and connect the component pin. Disable this. And now if we compile, we see our mesh. Let's go to the parent object, and as you see, it works correctly. Oh, don't forget to delete all the mesh sections in the parent customizable objects. We don't need them anymore. They are coming from child customizable object now. And now we have separated logic for the head into its own subgraph. We can do the same thing for the body, for the clothes, for equipment. But before we do that, what if we had several metahumans? Because this mutable graph can be used as a pipeline tool to convert vanilla metahumans to skeletal meshes that needed in your particular project. And currently our graph only works on Bruce. Let's fix that. One of the ways to do that is to create a struct with references to metahuman assets and build a data table with a row for each metahuman. We start by creating a structure. Let's call it st metahuman. Now in this structure we need to define skeletal mesh soft object references for face and body skeletal meshes. And we also need to define material instance soft object references for all the materials in the skeletal mesh. One of the convenient ways to do that is to copy a slot name from skeletal mesh into a variable name. Once it's done, we have to set the default values, otherwise the mutable won't be able to fetch the data in the graph. So these mHide materials, they are not material instances, they are material parents, and thus we cannot use them here, so we can just leave them empty for now. Let's set the default values for the face and the body, Bruce face mesh and Bruce body mesh, and our structure is ready. Now on to creating a data table. We select the structure that we created just now. And let's name it DT Metahumans. Great, now let's open data table asset and add a single row. And let's name this row Bruce. All our defaults are Bruce metahuman assets, so we don't need to change anything. We just save it. And let's go back to our face customizable object and update it so it can use our new data table. And here we need to do a couple of things. First, we need to swap our skeletal mesh with a data table. To import a data table, we just type table. It's a metahuman. And let's choose a table that we created just now. It is DT Metahumans. Again, there's a lot of pins. Let's hide them all and select only LOD0 face. Let's select only LOD0 face meshes. And here it is a one-to-one swap. We just can drag the pins from skeletal mesh to our data table. We can compile to test, and it is working. Now we can delete this skeletal mesh node, we don't need it anymore. Let's copy paste the data table and swap with this skeletal mesh as well. So we just hide everything. We searching for LOD1 section 0. It will be face LOD1 material 0. And we have LOD1 section 6. It will be LOD1 material 6. Let's swap those. We can delete the skeletal mesh node, compile, save, and our customizable object works the same way as it was before. One other thing that we need to change here is to make mesh sections to use materials that are coming from the data table. Let's copy our data table, hide everything, and search for shader so we can see only shaders, only materials. and enable every material. And now we need to connect it to the mesh sections. Let's do the same for LOD1. And now our face is generated using data from the data table. And to test if it's working properly, we can create another metahuman. Here I created a new metahuman from a preset called Cameron. And the only thing that we need to do is to populate this data table. We create a new row in this data table. Let's call this row Cameron. Now let's set the values. We'll select SKM Cameron face mesh for the face value, and for the body value we'll choose SKM Cameron body mesh. Now let's set all the material parameters. Let's save it. And here we're back to our face customizable object. Here we can see under preview instance, we have a new instance parameter called Metahuman. It is using the same name as our table node over here. This parameter has two options, Bruce and Cameron. And if I change to Cameron, we have a face of Cameron. But you probably noticed there is something wrong with this mesh. This is how Cameron should look like. We're having this problem because we're using Bruce DNA on Cameron mesh. To fix this problem, we have to supply DNA data linked to each metahuman. And I couldn't find a way to put DNA data into a table so it can switch together with our metahuman parameter. I believe this is because DNA workflow in Mutable is not that mature yet, and hopefully it will be fixed in newer versions. But for now, I found a workaround that works for me. Let's open our metahuman parent object and create a new group. New object group for DNA. For each metahuman, we have to create a new child object. We have Bruce child object, Cameron child object. Now those child objects need to have a DNA constants. Bruce DNA constant will be using a Bruce SKM Bruce face mesh, and Cameron DNA constant will be using SKM Cameron face mesh. And the object groups type would be at least one option. We compile this. In our preview instance parameters, we can see our new DNA parameter. Oh, don't forget to set the component name on both of these DNA constants. It is a bit awkward to select both of these parameters same way. In the future, I'm sure this workflow will improve, and for now, this is what we have. And here we go. This is quite simple, but generalized workflow for metahumans. It can be extended to fit your own projects. We didn't even scratch the surface what's possible with Mutable, but this is all we have time for, and thank you for watching. Goodbye.